We're all aware that modern technology is constantly developing. I suppose it's worth mentioning that robotics progresses too. But what is the point of all the effort experts put into creating robots? What exactly is the benefit to us? Well, robots' primary function in society is to help people by doing the repetitive, risky, or dirty work that humans prefer not to do. Simply said, robots help in every way possible. These days, robotic animals are being created and used to make people's lives easier. So, sit back and relax as technology now will show you some futuristic animals which you've probably never seen before. Plurobot. Did you know that experts had to examine X-rays of a genuine salamander's movement while it walked on the ground or swam in order to design this robot? This is why we could really tell why its design ended up looking like the real salamander. The robotic salamander was developed by scientists at Switzerland's Federal Institute of Technology in Lausanne. They used an artificial nervous system consisting of electrical circuits to power up this robotic animal. The 27 degrees of freedom in Plurobot's design make it possible to test more sophisticated mathematical models of the locomotor nervous system in the pursuit of more nuanced motor abilities. Besides its potential in the field of neurology, Plurobot has several exciting potential uses in robots for search and rescue and paleontology. Its low center of mass and segmented legs allow it to move confidently over uneven ground. It can swim thanks to its waterproof skin. This is why Plurobot could use those capabilities to aid in rescue missions. Bionic Flying Fox. Flying foxes, or fruit bats, belong to the family of bats which are the only animals capable of sustained flight. The Bionic Learning Network team behind it studied the flying fox in detail and encoded its unique flying abilities into the design. Festo's Bionic Flying Fox, with a weight of under 580 grams and a wingspan of over 90 inches, is equipped with a motion tracking gadget that constantly tracks its whereabouts and how far it has traveled. It is flexible enough to remain nearly crease-free even when the wings are folded in. Flying membranes are protected from further damage by the honeycomb structure of the material. Because of this, the Bionic Flying Fox can keep flying. Elume. Inspecting or maintaining something underwater has always been a time-consuming and labor-intensive operation. Thank goodness, experts are working on robots that can be used to make deep-sea exploration and construction easier. The engineers in Norway are responsible for the creation of this versatile underwater robot, Elume. Its primary function is to perform inspections, maintenance, and repairs on offshore drilling infrastructure. In the military, it might be used for things like detecting mines and keeping an eye on the ocean floor. The depth to which the Elume can dive is estimated at 500 meters. There's a motor on the inside of the robot that drives it. The operator may also stay updated on what's happening below ground with the use of cameras. Elume may be live underwater where they may be activated at any time, day or night, rain or shine. What's more to this is that greener, safer, and cheaper subsea operations are possible with this robotic animal. It has the potential to cut the price of underwater operations by as much as 90%. Okay, now I know you've all been wondering what the next robotic animal would be, but before that, I'd appreciate it if you'd consider giving this video a thumbs up and clicking the subscribe button so you never miss another video like this one. Going back, here's a giant six-legged robot creature that is helpful in studying the depths of the ocean. Crabster CR200. The discharge of the Crabster CR200 into the waters will provide a man-made threat to the creatures of the deep. The six-legged, over a half-ton robot is designed for the most hazardous underwater investigation and is inspired by crustaceans. This robotic animal is created by the Korean Institute of Ocean Science and Technology, which imitates the design of crabs and lobsters that survive in stormy waters but are still able to control their movements, unlike propeller-driven craft which do not perform well in fierce tides and divers who are restricted to calm, relatively shallow seas. The crabster is 1.8 meters tall while standing, 2.4 meters long, 1.3 meters broad, and 1.3 meters high when lying flat. Its 6 legs include 30 motors, and it weighs about 650 kilograms with cargo, providing the remote pilot plenty of control. The crab can adjust its position to changing current or pressure conditions up to a depth of about 200 meters as it creeps down the ocean floor. It searches the landscape for interesting objects using sonar and can transmit photographs using onboard cameras. Rowbird. The rowbird, created by Arium, is a special instrument for controlling wildlife and mitigating bird strikes that may be applied successfully, humanely, and quickly to reduce bird populations in a variety of industries. This is true because its regular operations cause the local bird population to gradually decrease. It's a cutting-edge approach that is safe for the environment and ideal for managing wildlife populations. It has a bird-like design and is so light that it can flap its wings because of its thorough composition. More polyfoam is used to build the wings in order to reduce overall weight without compromising the plane's structural integrity. Like a real bird, it flies with a smooth, effortless glide. It is piloted using a remote control device. Another Festo invention we have here is the Bionic Wheelbot. One of the most appealing aspects of the Bionic Wheelbot is that, in contrast to its spidery inspiration, it won't give even the most phobic of individuals the willies. The Bionic Wheelbot can roll and walk thanks to its 8 legs. A total of 15 tiny motors that fit in the body and knee joints are used to regulate them. Additionally, 14 automatic locking worm gear units make sure that Spider only uses energy to move its legs and not to maintain its upright posture when at rest. The Bionic Wheelbot performs a full-body somersault while in rolling mode like a real flick-flack spider. Because the robot contains an inertial sensor, it is always aware of its position and when to start moving again. Rolling, as opposed to walking, is consequently faster, and it can even climb steep slopes of up to 5%. The artificial spider utilizes 6 of its 8 legs to walk, leaving the 2 so-called push-off legs folded up. The Bionic Wheelbot walks with a tripod stride. 3 legs are left on the ground for each stride, while the other 3 are lifted, pushed forward, and then placed back on the ground. We now understand why so much time and effort was spent on developing these man-made animals. These days, robotic animals are being developed to aid humans by carrying out tasks that are tiresome, dangerous, or otherwise beyond human capacity. One thing I would like to ask you is, without these robots, do you think we're capable of doing those things? For more technological-related content, consider subscribing to our channel. This is Technology Now. We'll see you in the next video.